Okay, let's move na po sa atong new sample problem. So if you notice, we have a spring na po diri no nga sample. So we have a on sample problem number 4, we have a platform above the spring. So ang mass ani is just negligible. So dito na siya kabalakan ang mass or work done due to the platform. But we note that the ends of this platform kaniyang side is na IPC. So gihikot siya here. So that the 0.4 meter long cords keep a 1 meter long spring compressed 0.6 meters when nothing is on the platform. Okay. So naay spring, naay platform. So iyang giingon diri nga git-tied down ang platform. So sa ato pa na din siya original nga position. So this is the spring at a certain height. So iyang original height, so we have a original height here. Let's say this is our H or S. And then so that the 4-meter long cord, so that's why we have a 0.4 meter here nga length niya, length sa cord. Keep a 1 meter long spring compressed 0.6 meter. Sa to pa, ang total length ni spring is 1 meter. And then, gi-compress siya 0.6 meters. Kani, when nothing is on the platform. So, pasabot ani is, kung wala siya gi-compress, wala siya gibita due to the cord, ang ang length is 1 meters when nothing is on the platform. Kaya naman tayo gipisi, gihikot niya, so 0.4 meters man ang pisi. So, pila yung compression? So, we have a compression or yung displacement equal to 0.6 meters when nothing also is on the platform. So, niya mo abot siya 0.4 iyang 0.6 iyang compression. So, gibitad siya. Or we call this the DS. So, unsay buhaton na to? Okay, let's make this our first situation. So, atong first situation na is dili yung total length but this length. Next, naay 2 kilogram block. Kani, placed on the platform and released from rest after the platform is pushed down 0.1 meters. So from this point here, from our initial position, gi-push down pagyud siya. So that is 0.1 meters. Determine the maximum height h the block rises in the air measured from the ground. So gi-ask din ta pila yung maximum height nga na-reach ani ni block. Okay. So if you notice gi-push na gyud to si force, si spring. Sa ato pa si spring is while ato siyang gi-push dadto pa down, na siya force going upward. So, atong buhaton is, we, sa pay given na to lain diri, determine the, so we have a K here for the spring. This is spring constant, which is equal to 200 Newton meter. So, kani siya natay actually, medyo libog ni siya, no? Natay initial nga ang spring, 1 meter. And then, apo isa ka initial nga, 0.6 meter, ang iya ang iyang displacement. Then sa ani nga condition iyang initial nga displacement is 0.6 meter plus 0.1 meter. So ato na siyang i-kuan ato na siyang tagsa-tagsaon para mas masabtan nato. So sa sample problem number 4, ato ang initial stretch ni string from this problem dili kani atong gi-analyze from this problem. So we know that naka-stretch na siya 0.6 meter plus from this starting point, from this situation nga naanay block, that is already 0.1 meter. So ang total niya nga stretching or displacement ni spring is 0.7 meters. And then what else unsa pay laing given? The mass of this block is 2 kilograms. So, ang yang weight ana is just equal to 2 kilograms times 9.81. that is 2 times 9.81, 19.62 newtons. And then, yeah. Okay. So, next na tubuhaton, again, always draw an FBD. So, if you draw an FBD, duha ra ka force ang gaakad to. Na ay weight ni block, which is equal to 19.62. And then, we have the force due to spring F sub S. So, next na tubuhaton, again, don't forget the work energy principle, T1, the first initial kinetic energy plus the summation of the work or the total work that is equal to the final kinetic energy. Another day na nga given na to is that the initial velocity is equal to 0 kay starting from rest man. So ito ang initial kinetic energy which is equal to 1/2 m then initial velocity squared. We know our initial velocity is 0, that is just our initial kinetic energy is equal to 0. So imong kalibugan niya nga nag V sub not V naught ko diri and then this is V1. So this symbolizes initial kinetic energy. This also symbolizes initial kinetic energy. So this is 0. And then ang total work done, unsay work done nato due to this particle. So atong gi-expect nga motion is upward, right? So we have a work due to spring. Let's denote as U sub S. If inyo madumduman, work due to spring is negative 1/2 K times the final square of the final position minus square of the initial position. So we have our, so actually kani siya nga position, this is not nga kuano, this is the displacement nga position. So our initial displacement kay gi-push man siya down is 0.7. Okay, so we have here US is equal to negative 1/2 times the K is equal to 200 Newton per meter. So that is equal to 200 Newton per meter times, ato sa iyat bang ha. So initial position nato is, or initial displacement is 0.7 meter squared. And then what is our final nga displacement? So final displacement nato kumubuhi-an na siya is balik siya sa original niya. So this is 0.4 no from the ground, or ang iyang displacement, final displacement will just be equal to 0.6. So our final displacement is 0.6 squared. So work done due to the spring is, we have a negative 1/2. So negative 1/2 times 200 times 0.6 squared minus 0.7 squared. We have 13. So ang unit is, this is 13 joules. And then we have here the work due to the weight, which is equal to, say, work due to the weight. So we have the force times the displacement. So that is 19.62 times, so unsa yang distance or displacement. So ang work due to the weight, so ato among final nga kinetic energy nga pangitawon is kani man siya, taman man siya diri, and we don't know this height. So ang displacement due to the weight, again ang displacement is the change man na siya sa height. So we are going to use this displacement. So pila man na siya? That is times the h minus 0.3. So imong kalibuga, ang distance always sa work is ang katong displacement. Dili kani, but rather from the initial to its final, that is the displacement. Or 19.62 h minus 19.62 times 0.3, 5.886. And then what is our final kinetic energy? Okay, so we have our T2, 1 times 1 half times the mass, final kinetic energy squared. So since atong pangitaon man is ang maximum height sa block, diba, if you remember, yung maximum height is, ang yung velocity at maximum height is 0. So gikan dire pag musaka siya thrown upward, ang yung velocity will becomes 0. That will be the maximum height. Sa to pa kay 0 man ang final velocity. So ang final kinetic energy nito is 0. So rewriting or substituting these values in this equation, we have 0 plus 13 joules minus 19.62 H minus 5.886 is equal to 0. We will have 19.62 H is equal to 13 minus 5.886 is equal to 7.114. Then we can solve for the H, which is equal to 0.363 meters. But this is questionable because because ang H, diba, we have the H which added pagid sa 3. And then we notice that we have something wrong. We forget to write the sign. So the sign convention for the work done due to the weight is, since the weight is going downwards and the motion is going upwards, then this is negative. So if you notice, dako jud og effect si weight, diba? So we write the whole equation again with the correct sign convention. We have minus the weight, which is minus 19.62 H minus 5.886 is equal to 0. So it is important to note for the sign for each conventions. So we have here the 13 minus a 19.62 H, and the negative of a negative, that is a positive, plus 5.886 is equal to 0. So inyo makita, no? This is 13 minus 5. Here we have 13 plus 5. So we have a 19.62H is equal to, so 13 plus 5.86, that is just equal to 18.886. Solving for H, we have 18.886 divided by 19.62. Finally, we have the correct value of H equals to 0.963 meters. So if you notice, no, dako kayo changes if we do not take regard the sign convention for each works nga done. So this is the spring, positive 13 joules, and then this is the work done due to the weight. So negative siya due to the direction of the motion. And then ang ato ang general nga formula for the spring is this is already negative 1/2 ks squared, or the square of the displacement. So don't forget, force times the distance, but ang atong distance na pasabot is ang displacement.